Section 1.5, Using Problem-Solving Strategies and Models. Basically, this section is applications and word problems. So oftentimes I hear that if you can just get the problem set up, then my students can solve the problem. Well, it makes it easier to solve the problem if you first make a verbal model. And a verbal model is taking the word problem and putting the equation into words. Once you have it into words, then you can substitute in the math symbols, and then it becomes an easier problem to solve. Some problem-solving strategies that we're going to use, and this list is by no means a full list of problem-solving strategies, but some of the more common problem-solving strategies are to use a formula, to draw a picture, or to look for a pattern. So the first problem, the driving distance between Boston, Massachusetts and Cleveland, Ohio is about 660 miles. If you drive this trip in 12.5 hours, what is your average speed? Well, we should recognize that we're dealing with miles, we're dealing with hours, and we're dealing with speed. So one of the first things that should come to mind would be the distance formula. Distance equals rate times time. We know the distance. Our distance is 660 miles. Our rate, that would be our average speed, so that's what we need to find. And our time is 12.5 hours. Now this becomes a very easy problem to solve. To undo multiplication, we need to divide both sides by 12.5 to get the r by itself. And when we put this in our calculator, we get 52.8. And again, the label is miles over hours, so our rate is miles per hour, and this is our answer. Number 2, the table shows the number of seats in each of the first 4 rows of an auditorium. The remaining 16 rows follow the same pattern. So you can see that the number of seats depends on the row. So there's many different strategies you could use. You can notice that the number of rows increases by 1 each time, and every time we add another row, we add 2 more seats. So we might be able to start off, first of all, we're going to say that y is the number of seats. We need to define our variable, and x is the row number. And you can see that our number of seats is always twice the number of our rows. We're multiplying by 2 because we're adding this 2 on each time. However, if I put in 1 for my x, I get 2. If I put in 2, I would get 4. I'm still off by that quantity of 10, so you could see that we need to add 10. And now let's check this. If we plug in 4 for our x, I can see that I'm going to get 18 seats. So now I want to know the number of seats in the last row. Well, there's 4 rows and there's 16 more rows, so that means there's a total of 20 rows. So in the 20th row, I'm going to plug in 20 for my x, and when I simplify this, I see that there are going to be 50 seats in the last row. Number 3, you're hanging 3 pictures on a wall in your home that is 16 feet wide. The width of the 3 pictures are 2 feet, 3 feet, and 4 feet. You want the space between the pictures to be the same, and the spaces to the left and the right of the group to be 6 inches more than the space between them. How should you position the pictures? Well, this problem is most easily visualized if I draw my 16-foot wall, and then I realize I have 3 pictures. My first picture is 2 feet, my second picture is 3 feet, and my third picture is 4 feet. So now this is a 16-foot wall. The space between the pictures is going to be the same, so we're going to let x be the space between the pictures. But it also says that the space to the left and the right need to be 6 inches more than the space between them. So we are going to add x plus 6, correct? No, this is not correct. You need to be very, very careful. We are talking, everything we're talking about in here is 16-foot wall, and each of my pictures are feet in length. And the space here is 6 inches more. So it's correct that we're going to be adding something, but we need to remember that 6 inches is only half of a foot. So on each end is not x plus 6, it's x plus 0.5. So now, if we add up all these pictures and spaces that comprise our wall, we will end up with the expression for the equation. So x plus 0.5 is the space, plus the picture, plus the space, the picture, the space, the picture, the space, and that's going to equal our total wall. And this actually becomes a fairly simple equation to solve now. When we combine all our x's, 1, 2, 3, 4 of them, and we add all our numbers, 2 plus 3 is 5, plus 4 is 9, plus a half is 10, and that equals 16. And now you can go ahead and solve this picture, or solve this equation. When I solve it, I get x equals 3 halves. So now going back and answering the question, making sure that we answer the question that's asked in the question, or in the problem. The space between the pics is, or each picture is 1.5 feet, and there's 2 feet at each end of the group. And number 4, your pay-as-you-go cell phone plan charges 8 cents per minute for weekday or daytime calls, and 5 cents per minute for night and weekend calls. If you made a total of 220 minutes of calls and your bill was $13.16, how many minutes of night and weekend calls did you make? One thing that I want to stress is that you need to start getting in the habit of defining your variables. And one very easy way to define your variables is to always look at the question. How many minutes of night and weekend calls did you make? So x is going to be the number of minutes of night and weekend calls. So if x is the number of night and weekend calls, how many minutes of daytime calls did we have? Well, remember when I went over this in class, if I have a total of 220 minutes, if 10 of those minutes are night calls, then 220 minus 10 is going to be the number of daytime calls. If I have 120 night calls, then 220 minus 120, or 100, would be the number of daytime calls. So in terms of x, if x is the number of night and weekend calls, then 220, the total number, minus the number that I've used up at night, what's left is going to be my daytime calls. Now remember again, we're dealing with money, and we're dealing with a number of calls. So again, our model, verbal model, would be the price times the number of night and weekend calls, plus the price times the number of daytime calls, is going to give us the total price. Because keep in mind that this is a price per minute, so it's not actually just a price, so our unit conversion would still cancel out. So, how much is a daytime call? A daytime call is 8 cents. Again, make sure that you're changing your 8 cents into proper money, so 0.08, times 220 minus x, the number of daytime calls, plus the price of my night calls, a nickel is 0.05, times the number of night calls, and that's going to equal the total bill. Now you need to distribute and solve this equation. I had made an error on that last one and I corrected it. It was 17.6, not 17.16. And now at this point, my last step, dividing by negative 0.03, and I see that x is 148. Now, 148 what? Well, this is another reason that it's good to define our variables, because we've defined x as the number of night and weekend minute calls. So there's 148 minutes of night and weekend calls. So that concludes our notes for section 1.5. This is only 4 problems. You might see the homework and think that we didn't do any problems like those in the notes. There's a lot of different kinds of word problems, and again, the thing that you need to do is make sure that you are writing a verbal model. If you can take out of paragraph form and put into an equation, verbal equation, plugging in the labels and the numbers is a lot easier then. Be sure to come to questions with class. Be sure to come to class with questions, and please don't forget to go back and do the notes check. Thank you.